Hey, listen up, there's a red alert! NASA supercomputers have calculated that there are only 2,021 years left until the end of the Earth. Our planet is about to… oh, wait a minute. Oops, I'm sorry. I thought these zeros were a mistake. Well, the research actually says 1,000,000,2021 years in the future. Whew, that's a relief. Breathe normally. Still, this means that our planet officially has an expiration date. And no, this is not science fiction. It's a very real study that shows how, why, and when life on Earth will end. So, thanks to NASA and Japan's Toho University, we can now mark the calendar. It'll happen in around 1 billion years. But what about how and why? Well, even as recently as the early 20th century, scientists still didn't know what powered the sun. One of the first big ideas was that the sun was basically a giant piece of charcoal, just a huge ball of fire burning some kind of fuel. But that was easy to rule out. At the rate the sun puts out energy, it would have burned through that kind of fuel in just a few thousand years. And even back then, geologists and paleontologists already agreed that Earth was at least 100 million years old, if not more. That meant the chemical burning couldn't have possibly kept the sun shining for that long. So, scientists turned to another, more nerdy theory – gravitational contraction. This idea was that the sun shines because of its own weight. Its gravity pulls all the gas inward, squeezing itself tighter and tighter. It's kind of like warming your hands by rubbing them together. We know that gas giants like Jupiter and Saturn are slightly contracting under their own weight and giving off more heat than they get from the sun. So yeah, gravitational contraction, also known as the Kelvin-Helmholtz mechanism, is very much real, but it's not what powers the sun. When researchers did the math, it showed the sun could only shine like that for about 20 to 30 million years. Eventually, scientists learned that the real secret behind the sun's power and longevity was something way more powerful – nuclear fusion. Now, deep inside the sun, it's unbelievably hot. We're talking 27 million degrees Fahrenheit. And it's under crazy pressure because the sun is so big and heavy. All that heat and pressure squashes hydrogen atoms and forces them to stick together. When 4 hydrogen atoms get squished hard enough, they turn into something new – a helium atom. When that happens, a little bit of their mass turns into energy, and that's what becomes sunlight and heat. For centuries, people feared the sun would someday go cold, and that will happen, eventually. About 5 billion years from now, our star will run out of hydrogen, and gravity will take over. But long before that, Earth will already be toast. According to a NASA life extinction prediction, our planet will become a scorched, uninhabitable rock, not because the sun will go out, but because it will burn too hot. It turns out that those old apocalyptic ideas were not completely off. The sun will destroy life on Earth, just not by going cold. But why? Well, it's because, with time, the sun is getting brighter. And I'm not talking about its mood. It releases more energy. It's a slow, natural side effect of the nuclear fusion we just mentioned. Deep in the core, the sun has been fusing hydrogen into helium for billions of years. But as more helium piles up, the core gets denser and hotter. Think of it like a pressure cooker. The more pressure builds up inside, the more heat rises from within. That extra heat speeds up fusion, which means more energy gets released, and the sun starts shining just a little bit brighter. It's not dramatic, we won't notice it in a lifetime, but the future-proof androids we're going to build just might. With time, the extra heat adds up. The sun is already about 30% brighter than when the Earth was born. But life decline is going to happen much earlier, even before the given deadline. As the sun keeps cranking up the heat, Earth is gonna sweat. The extra sunlight raises global temperatures to the point where the ocean surfaces hit around 117 degrees Fahrenheit. That's hot enough to mess with the planet's entire climate system. Water vapor begins to rise from the oceans and accumulate in the upper atmosphere. This causes even more heat to be trapped, creating a thick, humid layer around Earth. Scientists refer to this ongoing cycle as the moist greenhouse effect. The rising temperatures aren't just drying out our planet, they're also harming plants. Plants rely on carbon dioxide from the air to grow and thrive. However, as Earth warms up, certain natural processes can take too much carbon dioxide out of the atmosphere. When that happens, there won't be enough CO2 left for plants to survive. Forests will disappear first, then grasslands, bushes, and even the toughest plants that usually handle extreme heat. This all will lead to oxygen collapse, because plants and CO2 are crucial for photosynthesis. In simple terms, this is how plants use sunlight, along with water and carbon dioxide, to create their own energy and produce oxygen as a waste product. Right now, oxygen makes up about 21% of Earth's atmosphere. But once it drops below even 1%, complex life as we know it will most likely disappear. Earth's biosphere will shrink to just a few microbes and extremophiles, hiding deep underground. But even they won't last long. It's worth noting that scientists ran two versions of the simulation, one with life like we have today and one with none at all. Surprisingly, both worlds lost their oxygen at about the same time, around 1 billion years from now. That means plant life and photosynthesis do help, but they're not the main thing keeping oxygen in the atmosphere. It's actually a long-term chemical battle between volcanic gases and rocks that gradually soak up oxygen like a sponge. And even after most life is gone, the heat will keep going, causing oceans to boil. Not all at once, but slowly and steadily, the oceans will begin to evaporate into the atmosphere. But that vapor won't just come back down as rain like it does now. Why? The atmosphere will be too hot and thick for that. Instead, sunlight will start breaking the water apart, and hydrogen will escape into space permanently. Once it's gone for good. Basically, instead of raining back down, Earth's water will slowly leak into space until there's nothing left. Even before the last puddles vanish, life under the sea will be long gone. Once the balance of temperature and oxygen is lost, not even the hardiest ocean life can hold on. In the end, Earth will become something we can barely recognize, a dry, lifeless rock. There will be no water, no oxygen, and no life left. The oceans will be gone. The atmosphere will be thin and toxic. Even the most resilient microbes will have disappeared. However, the sun will still shine in the sky. Earth will keep orbiting just like always. It'll still be a planet, just without life. But long before that cosmic finale, Earth will already be uninhabitable, which raises the big question. So, what could future humans do about all this? Well, escaping sun radiation and extinction might end up being humanity's biggest engineering challenge yet. Maybe we'll build massive space colonies and leap from planet to planet, staying just ahead of the sun's deadly heat. Even if we terraform Mars, making it more Earth-like so we can inhabit it, it'll still be cooking in the same solar oven, just on a lower shelf. Or maybe we'll live in giant rotating space habitats, like O'Neill cylinders, floating mini-worlds with gravity and recycled air, water, and energy to support long-term survival. Those could drift farther and farther from the sun as things heat up. Or who knows? Maybe we'll upload our minds to the cosmic cloud or hop into a higher dimension and watch the universe like it's, Netflix. Okay, this is definitely too nerdy, and we're going deep into sci-fi territory. But whatever the solution may be, humankind has a long time ahead to figure out how to survive the eventual end of Earth and life, or maybe even preserve it in whatever form it takes. A huge asteroid, several hundred feet across, is dashing towards Earth through the black nothingness of the cosmos. Ooh. Brace for the terrible news. There's a 72% chance it might hit Earth in 14 years, with potential impact zones being North America, Southern Europe, and North Africa, some of the most densely populated areas on the planet. Astronomers have been keeping a close eye on the space invader for a few months, but now it's moved too close to the sun, and tracking it is impossible for the next 7 months. Of course, there's a 28% chance that it will miss our planet altogether. But what if it doesn't? Global devastation and destruction, that's what. Thousands of lives lost, billions and billions of dollars in damage, entire species wiped off the face of the earth, ruined cities and towns, destroyed fields and forests. We're left wondering whether it's the future awaiting for us. Well, now you can breathe easy. That's just a hypothetical scenario created by NASA to prepare for a situation like this. The space agency has been thinking about this kind of disaster for years. Even cooler, they run what-if asteroid exercises every 2 years to get scientists, state agencies, and international experts on the same page. The last one occurred in April. Over 100 people took part in that event. During such asteroid drills, experts pretend that a giant space rock is heading our way. Then they work through all the tricky questions they can come up with, like how big is it? Where might it hit? What should we do? It's like a massive brainstorming session to make sure that if it ever happens, we won't have to start from scratch. To make these scenarios feel as real as possible, NASA's Center for Near-Earth Object Studies gets involved. These are folks who track real asteroids and calculate their orbits. So they simulate months of asteroid observations, complete with uncertainties about its size, trajectory, and potential impact zones. It's the kind of uncertainty that makes decision-making way harder, just like it would be in real life. Now, if an astronaut really was aiming at Earth, it wouldn't be just one country's problem. It would be everyone's. That's why this exercise brings in international experts. In April, it happened for the first time. They worked alongside U.S. agencies like NASA's Planetary Defense Coordination Office and FEMA to understand how the world might respond to such a crisis, since an asteroid impact would have dire consequences globally. Now, the big question is, can we actually stop an asteroid from hitting Earth? Here, there are two main options experts consider. First, we could send a spacecraft to gather more info. If we knew more about the asteroid's size, mass, and orbit, we'd be able to make better decisions about what to do next. The second option is to try to deflect it. Basically, it means bumping the asteroid off its course so that it misses Earth. This might sound impossible, but NASA's DART mission has already proven that we can do it. 2 years ago, they crashed a spacecraft into a small asteroid called Dimorphos and successfully changed its orbit. It was a huge victory for planetary defense. But missions like that take tons of time to plan, prepare, and carry out. That's why spotting dangerous asteroids as early as possible is so important. Currently, NASA is working on a new telescope called NEO-Surveyor, which is set to launch in 2027. Unlike good old telescopes, NEO-Surveyor is designed to detect even the trickiest asteroids, including ones orbiting close to the Sun. It'll give us a better chance to act early and potentially stop an asteroid before it becomes a threat. If you still think that an asteroid impact is something out of science fiction and the threat isn't real, how about this? Early on Sunday, January 21st, a small asteroid about 3 feet wide entered Earth's atmosphere and luckily burned up over Germany. NASA's Scout Impact System spotted it 95 minutes before it hit and predicted exactly when and where it would arrive. At 1:32 a.m. local time, the asteroid turned into a blazing bright fireball, visible as far away as the Czech Republic. Some small meteorites might have landed near the impact site, about 37 miles west of Berlin. This is just the 8th time ever that an asteroid has been detected before it hit Earth. It's a splendid example of how tools like Scout are helping us track asteroids and prepare for anything bigger that might come our way. Here's another example. A small asteroid turned the skies over northeastern Siberia into a breathtaking light show on December the 4th, burning up harmlessly in Earth's atmosphere. The space rock, about 28 inches across, was spotted just hours before it hit. Thanks to observations from astronomers around the world, a special alert system managed to predict the impact to plus or minus 10 seconds. The asteroid entered Earth's atmosphere at 1:15 a.m. local time. The authorities were put on alert, but there was no damage reports. NASA's Asteroid Terrestrial Impact Last Alert System, or ATLAS, spotted the rock 12 hours before it entered the atmosphere. This makes it the 4th imminent impactor, which is an asteroid discovered within hours of its expected impact, detected this year, and the 11th overall. Now, China also has big plans for planetary defense. They're working on their first mission to hit an asteroid, and it's got a double purpose. One spacecraft will crash into the asteroid, and the other will hang back to study the whole thing for up to a year. In other words, it's not just about protecting Earth, it's also a way to learn more about the solar system. The target is an asteroid called 2015 XF261, which is a mouthful, and also about 100 feet wide. It flew by Earth recently on July 9, passing us at 31 million miles. True, it's pretty far away, but the space traveler was zooming by at a speed of 26,000 miles per hour, 30 times faster than the speed of sound. China is going to send a space probe to study the asteroid. They're hoping to learn more about its structure and composition, which could help us with future planetary defense missions. Then they plan to hit the asteroid with another spacecraft to test the impact, and the first space probe will stay there to observe the remains for up to a year. Timing is critical for this mission, and the asteroid offers some good opportunities in the next few years. Thus, in March and May of 2027, the asteroid will pass within 20 million miles of Earth. In April 2028, it'll get even closer. By that I mean 13 million miles away. A year later, in April 2029, the asteroid will end up just 4.2 million miles away, making it the best shot for a mission. Another decent chance will be April 2030. That's when the asteroid will pass our planet at 4.4 million miles. To give you some context, NASA's DART mission once targeted an asteroid 7 million miles away, and the trip took 10 months. So China's planners have to pick the right moment, depending on how long their spacecraft will need to get there. The mission is expected to start around 2027. At the same time, this won't be China's first attempt to target an asteroid. Back in 2023, they were planning a planetary defense test with a different asteroid, which is also about 100 feet wide. It's not clear why they switched to the current one, probably because the timing works better. Most asteroids are basically time capsules from 4.6 billion years ago, leftovers from when the solar system was just forming. Studying them could tell us a lot about how planets, including Earth, came to be. So, China's taking on something that combines planetary defense and pure space science. They're definitely making big moves in the space exploration game. When we say extinction, we usually think of dinosaurs that went to lunch with a humongous asteroid and were wiped out from the face of the Earth. We don't think of ourselves possibly going away in the near future. But what we forget is that there have been 5 mass extinctions that our planet witnessed in the last 500 million years, not just one. And we can be nearing the 6th one, where one of the species to possibly disappear are humans. The first great mass extinction came about 440 million years ago in the Ordovician period. Back then, life was mostly thriving in the oceans and along the coastlines. Biodiversity was great at the time. There were thousands of different species, trilobites, sea scorpions, and all kinds of weird-looking mollusks, and even fish. You name it, Ordovician had it. But then, the temperature around the planet started to drop. The overall warm climatic zones became colder and colder, until the oceans got covered with thick sheets of ice. Most of the marine species weren't ready for such abrupt changes. Imagine a trilobite serenely crawling along the bottom of the sea and suddenly bumping into a glacier. Yeah, it's like living your entire life in a beach bungalow, only to find yourself in an igloo one day. The event was dubbed Late Ordovician Glaciation, which led to Late Ordovician mass extinction. Over 60% of all species that lived in that period disappeared. Only ancient fossils were left for paleontologists to discover hundreds of millions of years later. Nobody still knows exactly what caused the temperature drop at the time. The main theory is that the CO2 levels in the atmosphere fell sharply. It led to cooling down the entire surface of Earth. But the reasons for such a collapse are still under debate. However, that wasn't the worst mass extinction event in the history of our planet. Despite more than half of all living creatures being wiped out, biodiversity on Earth restored itself in the following 5 million years. Life went on until another catastrophe struck. Within the span of 20 to 25 million years, from about 375 to 350 million years ago, several extinction events occurred. They were like pulses that damaged a lot of marine species. Arthropods, like scorpions and mites, lots of various fish, including sharks, all were in decline. Overall, more than 75% of all living beings disappeared back then, who were mainly in the oceans. The reasons for such events are even more unclear than those before the late Ordovician mass extinction. Most scientists now believe those waves were caused by changes in the sea level and a lack of oxygen in the oceans. A lot of plants quickly moved to land and adapted to living outside of water. And since they were the main source of oxygen in the ocean, all those fish and sea scorpions were in for a very unpleasant surprise. The booming growth of plants on land also removed much of the CO2 in the atmosphere and enriched it with oxygen instead. This led to an abrupt temperature fall again, and although no new ice age followed, many land animals couldn't adapt to the new conditions. The bitter irony was that the major part of them had just recently crawled out on land from the ocean, looking for a better environment. Ah, well. This was only the first wave, though. The reasons for the second one, that came about several million years later, are still unknown. Scientists think there could have been mass volcanic eruptions, or even meteor strikes, but those are just hypotheses. Then another 100 million years passed without much trouble. Species rose and fell, evolved and disappeared, but the cycle of life continued, until about 250 million years ago, when the third mass extinction event occurred. It happened in the Permian period, the last period of the Paleozoic era, and it was so catastrophic that it had all the chances of becoming the last mass extinction on our planet. Scientists are still unsure what caused so many species to be eliminated. But the fact is that around 96% of all living creatures in the world were gone. One theory suggests that volcanoes started being overly active. They threw millions of tons of methane and basalt into the atmosphere. Asteroid strikes might have added to the damage too. The sky was literally covered in dark clouds of ash. The proto-mammals and reptiles tried to hide from the black and gray mist, but it was everywhere. It was like hiding from the air itself. Another culprit could have been microbes that loved their methane-rich environments. They could have quickly spread in the oceans and literally choked the rest of the marine life forms there. But whatever the reason, the Permian mass extinction event was the most massive and destructive of all the Great Five. All life on our planet could have ended right then and there. But those 4% that persisted eventually spread across the Earth and started a new era. Yay! This time, they lived a peaceful life for only 50 million years. And then, whammo! The fourth great mass extinction hit. It was different though, slowly creeping across the planet over the last 18 million years of the Triassic period. The extinction occurred in numerous short pulses, wiping out several species at a time. A slight climate change here, an abrupt temperature fall there, and very upset animals and fish all around. The main reason for that was again the volcanic activity at the time. Fiery mountains started spewing out ash and gas once more, lowering the oxygen levels and suffocating life. Well, that was harsh. The gases and other substances thrown out of the volcanoes' mouths changed the Earth's climate again. Sea levels rose because of that, and some researchers believe even the pH levels were altered. That means the marine life that used to be swimming peacefully in more alkaline waters suddenly found itself trying to survive in acid. But apart from causing bursts of extinction, these changes also ushered in the era of dinosaurs. It didn't begin immediately, of course. Some species evolved and slowly grew into the mighty animals we've heard so much about. Their extinction was the last of the Great Five, and certainly the most well-known. About 65 million years ago, when dinos were still ruling both land and ocean, an enormous asteroid came from outer space and fell right on Earth. The impact was so powerful, it left a huge crater in the Yucatan Peninsula, and the explosion sent billions of tons of debris into the air. The dinosaurs that lived far away from the impact zone raised their heads and saw black and churning clouds blocking the sun. It remained for years, drastically dropping the temperatures. In addition to the cold that followed, the asteroid hit a carbonate rock that had a lot of flammable material in it. The impact led to an explosion. The chemicals mixed in the air and produced sulfuric acid, and that acid fell down in the form of rains, altering the pH of the oceans. Aquatic creatures that were again used to more alkaline waters went, "Oh, come on!" That didn't help, though. The changes were abrupt and severe. About 75% of all animals and plants went extinct in a matter of years, unable to survive the new, harsh conditions on the planet. But some persisted. Many of them were reptiles, like crocodiles and turtles, which managed to survive even up to this day, looking almost the same as they did back in the dinosaurs' days. Others were mammals, which had lived in the shadow of the mighty dinos and hid from them in dark corners. But now that the giant animals were gone, they began to flourish, bringing in the Cenozoic era, the one that lasts to this day. And today, we might be witnessing the sixth great mass extinction. According to scientists, with the evolution of humans, a lot of different plants and animals have gone from the face of our planet, never to return. The good thing is, mass extinctions have always happened over a span of several million years, so we might still have time to recognize it, prepare, and counteract. What do you think? Shall we? Now, our planet has gone through 5 mass extinctions. One of them was so bad, it wiped out over 95% of life forms on our planet. Scientists think they might have found the culprit: volcanoes. Scientists took some ancient rocks from a dozen global locations and found elevated levels of mercury, which was released by volcanoes millions of years ago. This points to volcanic eruptions as the probable cause of the Permian-Triassic extinction event. The mercury didn't just come from rocks, it was from the atmosphere. This means that when the volcanoes erupted, they released this poisonous gas into the air. They produced about 720,000 cubic miles of ash, vastly more than the infamous eruption of Mount St. Helens. The gas left a trace that marks one of history's most significant catastrophes, setting the stage for the age of dinosaurs. These eruptions most likely released mercury by igniting large coal deposits. Shallower waters showed mercury spikes right at the extinction's main horizon, while deeper sections recorded spikes tens of thousands of years earlier. This could mean that the effects of the volcanic activity and the extinction it triggered varied across different ocean depths. That means that the extinction was prolonged and complex. It not only caused significant climate warming at the time, but also led to some other toxic events, like acid rain, which made the situation even worse for plants and animals. Although few things have made it from the Permian period to the present day, we can get an idea of what the world was like back then from the fossils found in eastern Kansas. Now, 252 million years ago, the Earth was thriving. The Earth's continents were coming together to form the supercontinent Pangaea. The land was mostly dry, and the Earth looked like a harsh, arid desert, vast stretches of land with minimal water sources. The climate varied from scorching summers to frigid winters. There were some plants here and there, mostly conifers, large ferns, and primitive mosses in places with more water. The Earth was dominated by dinosaur-like creatures like pelycosaurs or therapsids, often called mammal-like reptiles. There was also the fierce Dimetrodon with its awesome snail-like spine. These three were the top predators of their time. Smaller reptiles and amphibians also populated the landscape, alongside burgeoning insects like beetles and dragonflies, which thrived during that dry time. But all the interesting stuff mostly happened in shallow tropical seas. Marine environments were bustling with life: rich coral reefs, shellfish called brachiopods, animals known as bryozoans, and large single-cell fusilinids, which kind of look like they're covered in moss. Small funny ammonoids were quite popular as well, often hanging out in the oceans alongside brachiopods, bony fish, and sharks. Creepy trilobites, ancient marine creatures that first appeared 500 million years ago in the Cambrian period, but then persisted up to the Permian period. Trilobites were very diverse, active predators to scavengers or plankton eaters. However, almost all these beautiful creatures were about to disappear during the Permian-Triassic extinction. Now, this extinction was truly ruthless. More than two-thirds of amphibian and reptile species disappeared, and nearly one-third of all insect species were wiped out. Usually, the insects are resilient survivors, which shows how catastrophic this event was. Among these extinct animals was the terrifying Meganeuropsis, a giant dragonfly with a wingspan of nearly 2.5 feet, once found in central Kansas near Elmo. This place is famous for its rich collection of Permian insect fossils, including ancient crickets and cockroaches. For a while, it was a mystery what exactly happened. Theories range from a massive asteroid strike and natural pollutants choking the oceans of oxygen, to dust clouds, to cosmic volcanic eruptions blocking the sun and cooling the planet. There was evidence for each of these scenarios, but the recent discovery points to the volcanoes theory after all. There's also a possibility that the reason wasn't just the volcanoes. NASA-funded researchers have recently uncovered what might be the fingerprints of this ancient perpetrator, or at least one of its accomplices. By investigating rocks around the globe, they've found evidence pointing to a massive asteroid strike as a possible culprit. They found unusual molecules shaped like soccer balls, known as fullerenes. These molecules contain rare gases that usually come from space. This suggests that an enormous space rock, perhaps as large as Mount Everest, crashed into the Earth, contributing to extinction. There seems like there might have been a series of catastrophic events. The volcanoes were spewing vast quantities of lava and gas that altered the climate, Pangea was forming and disrupting weather and ocean patterns, and an asteroid decided to join in as the cherry on top. Lucky for us, nature is super persistent and always finds its way to be reborn. This just proves how resilient the Earth is. Now, what's interesting is this wasn't the only time that happened. The late Devonian extinction, which happened around 360 million years ago, is also tied to volcanic activity. Volcanic eruptions and the proliferation of land plants could have altered the nutrients flowing into the oceans. The Triassic-Jurassic extinction, which happened around 200 million years ago, a bit before the dinosaurs, might have also been a result of a volcanoes plus asteroid impact combo. And finally, about 66 million years ago, the last dramatic shift happened on Earth. Our planet went from the age of dinosaurs to the age of mammals. This momentous change is known as the KPG extinction. Just like the Permian extinction, it was a sudden event that ushered in new forms of life. And, once again, there are two major theories about what happened. The most popular theory tells us that the dinosaurs disappeared because of a massive asteroid. The Chicxulub meteorite smashed into present-day southern Mexico, creating the Chicxulub crater. The meteor was about 6 miles wide and hurtling towards Earth at incredible speeds. The impact was so powerful that it vaporized everything nearby instantly and released more energy than any other event in a billion years. The aftermath was catastrophic. Earthquakes shook the continents, and the ground itself heaved like a stormy sea. As the dust thrown up by the asteroid settled, it fell back to Earth like rain, heating up the atmosphere so much that forests worldwide burst into flames. Not far behind was a gigantic tsunami, stirred up by the ocean floor's upheaval, which swamped coastlines near the Gulf of Mexico. Not all dinosaurs perished immediately. In places like New Zealand, some dinosaur populations survived initially. However, a dark, ash-filled sky eventually covered the globe, blocking out the sun and plunging the world into cold and darkness. The long-term effect of the asteroid is what really sealed the fate for dinosaurs. Without sunlight, the food chain collapsed rapidly. Herbivores slowly disappeared, followed by the carnivores that depended on them, and the ash settling back to the Earth exacerbated the environmental upheaval, with fluctuating temperatures making survival tough. But there's another theory that says that, like with the Permian extinction, the asteroid was just the cherry on top. The dinosaur extinction was inevitable because of the volcanoes. Around 1 million years before the dinosaurs' demise, massive volcanic activity began under where India is today. This event created the Deccan Traps, a vast plateau formed from layers of lava that covered an area as large as France. For hundreds of thousands of years, these volcanoes spewed sulfur dioxide and carbon dioxide into the atmosphere. This turned the skies dark and the rain acidic, poisoning food sources and turning oceans into toxic baths. These changes were gradual but relentless, stressing ecosystems, breaking food chains, and leading to a slow but steady decline in many species, including the dinosaurs. Although it's not certain which theory is true, scientists now think that both were equally to blame. Maybe one day we'll have a clear picture of how the reign of the dinosaurs came to such an abrupt end. So, what's going on with all the news about the sun? Some say that the sun is getting angry. Well, what does that mean exactly, and should we be concerned? Frankly, yes, we should be concerned. It's generally not a good thing to get too much sunshine. The ultraviolet component of sunlight is harmful to the skin. That's why humans have adapted a spectrum of skin pigmentation. The more sunlight there is to protect ourselves against, the more pigmentation we need. Big floppy hats and, of course, bottles of high SPF oil-free sunscreen help too, especially for fair-skinned people. But what is planet Earth going to do? First, let's get a good estimate of just how angry the sun is likely to get. The sun usually goes through an active-calm-active cycle every 22 years, with highs and lows occurring every 11 years. Why that happens, no one knows, it just does. There's probably a reason, but scientists haven't figured it out yet. They do know that, with each cycle, the sun reverses its magnetic poles. That in itself is pretty astounding, especially when you consider that Earth hasn't reversed its magnetic poles in the last 600,000 years. Lately, the sun has been extremely calm, the calmest it's been in over 100 years in fact. That's unusual too. The active-calm-active cycle has turned into an active-calm-calm cycle. But that's changing, and it's why we are notifying Brightsiders about what to expect in the coming few years. The terms calm or active or angry refer to the amount of high-energy radiation that the sun gives off. Thankfully, the amount of visible light the sun gives off doesn't change very much. That would be a serious problem. If the sun were to get just 6% dimmer or brighter, the Earth would either freeze or fry. Observing sunspots is the easiest way to measure how active the sun is. The more sunspots that are visible, the more active the sun is. A graph, known as the butterfly diagram, tracks the 11-year period of sunspot activity. The butterfly diagram shows how sunspots disappear regularly from the surface of the sun and reappear regularly in other locations. NASA predicted that the present cycle of solar activity would be calm, like the previous one. But it's starting to look like that is not the case. Presently, we are in solar cycle number 25. That's the 25th 11-year solar cycle since 1755, when record-keeping began. This cycle of solar activity is expected to peak in 2025. The sun has already exceeded the number of sunspots NASA had predicted. So, it doesn't look like this solar cycle is going to be a calm one. It looks like we are going to have some very active sun-blasting radiation on Earth for the next several years. In early February 2022, 40 out of 49 SpaceX communication satellites in orbit above the atmosphere were destroyed by an explosion on the sun. High-speed electromagnetic plasma gas from the sun, known as solar wind, caused the Earth's atmosphere to compress, and Elon Musk's satellites lost their orbital integrity and crashed back into Earth. Sunspots look like dark spots on the sun, but they aren't dark. They're just not as bright as the surface of the sun. To get a better idea, take a lit 25-watt light bulb and hold it in front of a lit 100-watt light bulb. The 25-watt light bulb will appear dark. That's the same way it is with sunspots. Sunspots on the surface of the sun almost always come in pairs. This is because sunspots are magnetic storms in the plasma gas of the sun. One sunspot will be magnetic positive, and the other sunspot will be magnetic negative. Between the two sunspots, which can be many times bigger than the Earth itself, there flows an electric current that carries a fiery arc of ionized gas with it. Solar flares are something else we should be concerned about. They are powerful electromagnetic explosions on the sun associated with sunspots. As the superhot plasma gas on the sun churns and twists, it also twists the magnetic field lines in the sunspots. When these lines snap, a powerful explosion releases X-ray and gamma radiation at the speed of light. Visible gases are also released. Solar flares have a classification system according to how powerful they are. X-class solar flares are the most dangerous. This type of solar flare can cause radio blackouts across Earth and harm satellites, astronauts in orbit, and even passengers on high-altitude airplanes. M-class solar flares cause spectacular aurora at the North and South Pole areas on Earth, while C-class solar flares have almost no effect on Earth. But solar flares are not the biggest explosions on the Sun. CME stands for coronal mass ejection, and these are much more massive than solar flares and more dangerous when they're headed our way. As the name indicates, coronal mass ejections are explosions that originate on the Sun's corona. They hurl millions of tons of hot ionized gases outward from the corona. The word corona is derived from the Latin word for crown, and it's the layer of thin bright gas around the Sun's surface. The corona of the Sun is much hotter than the surface of the Sun. The surface itself is about 10,000 degrees Fahrenheit, but the corona is somewhere between 1 to 2 million degrees. The why and how the corona is so much hotter than the surface of the Sun is another major mystery that scientists have yet to completely work out. A recent theory claims the corona is heated by sound waves and the Sun's nuclear reactions make a lot of noise. Project GONG, which stands for Global Oscillation Networking Group, was set up on Earth to monitor the sound waves on the Sun. Cool, huh? Turns out the Sun is ringing or oscillating like a bell. And we have 5 observation sites across the globe, one in India, Australia, one in the Canary Islands, one in Chile, and one in California, that keep a constant watch over the 10 million sound waves moving on and around the Sun. Now that the Sun is entering an active phase, we can expect to see more powerful CMEs heading our way. The gases expelled by the Sun are ionized and stripped of electrons by the intense heat. This causes them to form a proton storm that can travel through space at speeds of around 500 miles per second. These positively charged atomic nuclei will mostly be blocked or deflected by the magnetic field that extends around Earth. Our atmosphere is no help against a proton storm, although the last mile of air above the surface of the Earth stops the harmful X-rays from solar flares. The particle wind from the Sun can only be stopped by Earth's magnetosphere. We can look forward to some spectacular aurora around Earth's magnetic poles, and it's very possible that these aurora will extend down to the mid-latitudes when the Earth is moving through a coronal mass ejection. Currently, the United States has a space probe headed for the solar corona. Because the corona of the Sun extends outward for many millions of miles, the Parker Solar Probe, as it's called, is cruising 3.8 million miles from the surface of our star, or about 1/10 the distance to Mercury. The probe is experiencing temperatures of 2,400 degrees Fahrenheit, but it is also kept at perfect room temperature. A 4.5-inch thick carbon composite heat shield protects the telescopes and magnetometers in the probe that measure the intensity of the solar wind. The 5 antennae that protrude into the coronal gases are made of a niobium alloy, which can withstand the extreme temperatures of the corona. The recent double calm cycle of the Sun is a bit concerning when trying to predict how active the Sun will get this cycle. The sunspots completely disappeared for a long time from the entire surface of the Sun. It is as if the magnetic distortions we usually see on the photosphere of the Sun had collapsed into its interior. Intense magnetism is coming to the surface now and breaking through into the corona. The National Center for Atmospheric Research in Boulder, Colorado, is predicting that this solar cycle, cycle number 25, will be one of the strongest ever. The last solar cycle was very calm, with a sunspot count of only 116. The average is 170. But the prediction for this cycle is between 210 and 260 sunspots, which would be one of the strongest cycles ever. We stand to lose more satellites to a stronger solar wind. We can also expect electric grid overloads as the proton storm peaks in 2025. That means we should expect an interruption to our internet services as positively charged protons get into the wires, run into the transformers, and overload them. On March 12, 1989, a powerful CME hit Earth and created absolute havoc with our power grids. Will we experience anything of this magnitude in the near future? Well, stay sharp, Brightsiders. Hurricanes can be a lot scarier than we often realize, especially since they can actually trigger earthquakes. This surprising and frightening phenomenon, known as stormquakes, was discovered completely by accident not too long ago. It started with scientists trying to find out more about low-frequency earthquakes. We're talking about those earthquakes that are so weak that we can't actually feel the tremor. See, beneath our feet, the Earth is constantly vibrating in subtle, unceasing ways that we can't hear or see without the right equipment. This geologic hum, so to speak, is driven by the movement of oceans, which covers about 70% of our planet's surface. Scientists have found that this hum may actually provide useful records of environmental happenings. To figure out where it's coming from, experts used equipment known as seismometers. You can think of these devices as little ears pressed to the ground. They can pick up all sorts of vibrations, like fans jumping up and down at their idol's concert, airplanes flying by, or even super distant earthquakes shaking the ground. Very low-frequency earthquakes are hard to track over long distances because the signals they produce can look different on different measuring devices. To solve this problem, experts came up with a way to track these signals by combining readings from smaller areas, kind of like putting together a puzzle. But while doing this, they stumbled upon a strange set of events that looked a bit like the earthquakes they were studying, but were not exactly the same. The first weird thing they noticed was that this specific phenomenon was seasonal. It never happened between May and August, for example. That is completely different from earthquakes, which can pretty much happen any time of the year. The second strange thing is that earthquakes usually occur more in the western part of the United States, where the ground moves along cracks in the surface. But these new strange vibrations spread not just along the west coast of North America, but also over to the east side. So what could be triggering this new phenomenon? What they surprisingly discovered is that many of these tremors coincided with the same time that massive storms hit North America. So we are essentially talking about a chain reaction. What happens is that during a specific season, hurricanes or heavy storms can transfer energy into the oceans, creating very strong waves. These waves then interact with the solid Earth, producing intense seismic activity. These bursts of energy that are born from massive storms can radiate thousands of miles across continents, leading to what we now call stormquakes. It is believed that this phenomenon can trigger earthquakes at a magnitude of up to 3.5 on the Richter scale. This means it can be felt by many people, but normally doesn't cause any damage. But that doesn't mean we can all be relaxed now, as ocean waters can indeed increase the intensity of hurricanes. Just like what happened with the frightening Hurricane Milton, which recently left a path of destruction across Florida. The blue-purplish zone you're looking at is Hurricane Milton, seen from a satellite perspective. On October 9th, this hurricane sustained winds of 155 miles per hour and lashed the region with heavy rainfall, damaging winds, and life-threatening storm surges. Estimates show that the losses could be up to $34 billion, which could make it one of the costliest storms in United States history. What happened with Hurricane Milton was pretty tricky. It all started with some record hot water in the Gulf of Mexico. That warm water acted like a power-up, giving this hurricane the energy it needed to grow. And then, there was also this process called eye wall replacement that helped it get bigger too. We'll get to that in a moment. So as Hurricane Milton approached the coast, something unusual happened. It crossed paths with a fast-moving air current called the jet stream, which flows high up in the atmosphere. Now normally, the winds in the northern and northwest parts of a hurricane are not as strong as those in other areas. But because of this interaction with the jet stream, the winds in these parts of the storm became much stronger than expected. At nearly every turn, Hurricane Milton surprised everyone and intensified faster than we have seen in ages. It threatened to slam both Florida's west and east coasts with a dangerous surge of water, putting the bustling area of Tampa Bay, which is home to over 3 million people, at serious risk. So how did Milton become such a major problem? Well, the problem started in the eastern Pacific Ocean. Usually, hurricanes follow a fairly predictable path, spinning off of Africa's coast, sailing across the Atlantic, and gaining strength in the warm Caribbean waters. But Milton had a twist in its origin story. It began as the remnants of a tropical depression that crossed over the Yucatan Peninsula and met a stalled front in the Gulf. Once Milton got going, it didn't hold back. But when it hit those record-high ocean temperatures, it was like giving it an energy drink. The warm water and humid air were the perfect ingredients for a hurricane on the rise. Quickly, Milton's wind speeds increased by 92 miles per hour. So it went from a tropical storm to a Category 5 hurricane in less than 2 days, which is basically insane and off the charts. And if that wasn't enough, Hurricane Milton also went through this thing called eye wall replacement. Now, hurricanes spin around a mostly clear eye in the center. But overnight, Milton started forming new bands of rain on its outer edges, creating a second ring around its eye. This process helped Milton grow even bigger, spreading out the wind speeds and giving it a larger footprint. It's kind of like shedding its skin and getting ready to become even more powerful. Hurricane Milton also had this little wobble in its path, which changed where it was heading. You can think of it like a spinning top that gets nudged and wobbles a bit before finding its balance again. That wobble meant some areas could get either hit hard or be spared from the worst of the storm. Thankfully, Hurricane Milton weakened a bit because of some tricky wind changes up in the atmosphere until it finally made landfall. After that, it moved across the peninsula and headed out to sea, quickly losing strength as it pulled away from the warmer waters. Now, even though the damage was significant, the good news, if you can call it that, is that experts were honestly expecting things to be way worse. Still, it raises a question. How close was Milton's wind speed to the maximum? Or, in other words, is there a limit to how strong a hurricane can get? Well, the answer is yes, there is a speed limit for hurricane winds, but it's not a set number. Right now, the strongest a storm can get is around 200 miles per hour. But that maximum speed can change depending on many factors, like the heat in the ocean. Think of the ocean as the fuel for hurricanes. The warmer the water, the more fuel these storms have to work with. Experts believe that as the oceans continue to warm, they can ramp up the wind speeds and the impacts of hurricanes, making them a lot stronger. But other things can also help figure out how intense a hurricane can get. For example, the heat in the air and the temperature at the top of the clouds matter, as they also affect how fast heat moves from the ocean surface to the top of the storm. Some estimates suggest that maximum wind speeds could reach closer to 220 miles per hour until the end of the century. So it's definitely something that experts need to keep an eye on to help prevent future disasters. As we move forward, it's essential to keep researching and studying these storms. The more we understand them, the better we can protect ourselves and our communities. In September 1859, scientists observed the first confirmed powerful solar flare. The sun threw a large amount of radiation, energy, and plasma material into space. This was a massive and devastating disaster, but it happened 93 million miles away, so it probably wasn't such a big problem, right? Well, actually it was. A few hours after the flare was spotted, telegraph lines stopped working all over Europe and North America. Some of them sparked and caused fires. People realized that the sun was not only the source of light and warmth, but also danger. Scientists called that day the Carrington effect. The good news is that this happened in the middle of the 19th century and didn't cause serious problems for the planet. The bad news is that scientists are warning that in 2025, Earth will experience even more powerful solar storms caused by a coronal mass ejection. This is a giant cloud of plasma or charged gas. At one time, the sun can throw billions of tons of this material into space. Then, all this flies at high speed through space. Some of the material can reach our planet in 15 hours, the rest in a few days. During the journey, it captures and accelerates any charged particles encountered along the way, which increases its intensity and power. And then, this unstoppable array of energy crashes into our planet. It heats the upper layers of the atmosphere, increases its thickness, and disturbs the work of satellites. They slow down and lose altitude. Communication with satellites becomes unstable, GPS is buggy, data is poorly transmitted. Also, solar charged gas penetrates into our power grids, transformer booths, and stations. It leads to massive failures that ruin the work of the entire technological chain. A powerful solar attack on several power plants can trigger a power outage in a large city. The internet, phones, social services, networks, nothing will work. We may lose connection with each other. Many large companies would go bankrupt, and the planet may face economic crises. These are big problems, but not the most serious ones. Electric plants serve boiler houses and water pumping stations. Solar storms could stop water from getting to our homes. You wouldn't be able to buy groceries in stores without cash. Of course, we can restore all this, but we'll have to live in the Iron Age for a while. But the worst thing is that a prolonged solar storm can suspend food production. For example, this year, a geomagnetic storm caused by solar storms shut down GPS satellites that are connected with modern tractors, so farmers couldn't work. What would happen if such storms happened every day for a year? We would probably start missing many items in supermarkets. Besides, maritime navigation also depends on satellites. Thanks to them, ships calculate the latitude and longitude of their location. If the satellites are damaged, ships may get lost in the ocean. Even whales get lost in the ocean during magnetic storms. Many birds navigate with the help of magnetic field during long flights to the south. So, not only people, but also animals may experience serious problems. Solar storms heat the upper layers of the Earth's atmosphere and thus make the air thicker. The movement of satellites slows down because of this air resistance. They lose altitude, and one of these satellites is Hubble. Yes, the very telescope that provides us with incredible pictures of space. Scientists say that it will fail much earlier because of solar attacks. You've probably heard on the news that solar activity has recently caused electromagnetic storms on Earth. But fortunately, it hasn't affected our lives in any way. The only problem was headaches, high pressure, and mood swings during those storms. It seems like an ordinary thing, but scientists don't have a consensus on this topic. No one has proven exactly how and why magnetic storms affect our condition. Yes, during storms, the planet's atmosphere becomes less dense, and perhaps this affects our blood pressure, like it happens when the weather changes. So people with cardiovascular system problems should be careful. But the effect on our nervous system, fortunately, is quite insignificant. It's possible that when people hear about a coming magnetic storm and feel unwell, they experience a placebo effect. But there's also good news. All these charged solar particles interact with atoms and molecules in Earth's atmosphere. This interaction leads to beautiful northern lights. It's good to spend some time away from your gadgets and look up at the sky sometimes. One of the biggest storms occurred on March 13, 1989. On March 10th, the Sun ejected a gigantic volume of coronal plasma. The amount of that material was the size of 36 Earths. The solar cloud was flying to us at 1,000,000 miles per hour, and a couple of days later, it crashed into our planet's magnetic field. The collision caused a geomagnetic superstorm. People watched some of the brightest and most beautiful auroras in history. The light show covered most of the planet, but after a beautiful performance, problems followed. The solar storm was so powerful that it went through the atmosphere and reached Earth's surface. First, it disrupted the operation of satellites and then damaged electrical networks. For example, it destroyed a transformer at a nuclear power plant in New Jersey. Energy companies in Canada went down because of systems overloading. As a result, about 6 million people in northeastern Canada lost electricity for 9 hours. This was the largest power outage caused by a geomagnetic storm. Yeah, there were more powerful storms in the mid-19th and early 20th centuries, but the planet wasn't covered by so many power grids at that time. More powerful storms may occur in 2025. The question is, will we be ready for them? Careful study of solar activity can help us prepare. If we know in advance about an upcoming storm, then scientists can switch off some systems and turn them on afterward, theoretically. If the activity of the sun increases every year, then we'll have to come up with new innovative ways to protect ourselves. Who knows? Maybe scientists will cover all our electrical appliances and stations with a layer of special protective material. Anyway, we must do everything possible not to harm Earth's magnetic field. Because if this shield disappears, the surface of our planet will resemble that of Mars. But what causes these solar storms, and why do they affect us so much? Okay, imagine a guy with a nice hairstyle who goes to bed. In the morning, his head is a complete mess. The magnetic fields of the sun are similar to this tousled hair. When the sun rotates, these fields burst, get tangled, stretch, and tear. At those moments, they release huge amounts of energy into space. This is not a problem for the sun, as the fields are restored during the process called magnetic reconnection. Such emissions can cause trouble for the planets in our system. When magnetic reconnection happens, several phenomena can follow. One of them you've already heard about. It's a coronal mass ejection. But there's another terrible thing that the sun does, and it's called solar flare. Imagine a bright burst of solar radiation containing electromagnetic waves, X-rays, radiation, and visible and ultraviolet light. During flares, the sun releases an enormous amount of this destructive energy, and it spreads through space at the speed of light. It takes 8 minutes for this explosive wave to reach our planet. Fortunately, we don't get much damage from these flares because Earth's magnetic field and atmosphere protect us. Strong flares can disrupt radio waves in the upper atmosphere and affect the operation of satellites, but it's nothing critical. Another solar phenomenon is called a radiation storm. These are accelerated electrons and protons that move at a speed slightly less than the speed of light. Thanks to Earth's magnetic field, radiation storms don't harm our planet too much, but they pose a danger to astronauts and satellites. These particles can penetrate human tissues and lead to serious health problems in the way radiation does, but only if you're in space or flying a plane in the upper atmosphere.
This is John. John seems to attract all kinds of bad weather and natural disasters wherever he goes. See for yourself. One day, John notices his dog is restless. The pooch keeps scratching the entrance door and wandering around the house. He even tries to hide in the corner, howling and barking. When some mugs start to clink in your cupboard, John realizes what it means. The noise is produced by foreshocks, mini earthquakes leading up to the main event. Earthquakes often happen in clusters. After a few weak quakes, a much bigger one is likely to be on the way. Sometime before the disaster strikes, people might notice bizarre blue lights. Some of them seem to be coming out of the ground. Others are hovering in the air. These are earthquake lights. They may appear days or mere seconds before the ground starts shaking. Now, John is walking along the ocean shore. Suddenly, he sees the water retreat from the beach. Really fast. Uh-oh. John, run away as quickly as you can and find some high ground. A tsunami is coming. And your life might depend on how fast you react. If John spots a bizarre and unexpected rise in sea level, it can be another sign of an approaching tsunami. This happens in 40% of cases. The incoming water is the first tsunami wave. The second one, way larger, will come in about 10 minutes. John can also notice seawater bubbling, swirling, and creating bizarre patterns. It's another sure sign a tsunami is near. John feels there's something strange about the sun. Through his special super dark sunglasses, he sees that there's some uneven flares around the star's contour. If these bizarre rays are accompanied by auroras all over the world, they're a sign of a solar storm. Such storms are usually caused by disturbances in the sun's magnetic field. In this case, the bursts of gas and radiation on the surface of the sun get so massive and powerful that they can even reach our planet. Luckily, solar storms aren't really dangerous for people, but they can mess with electricity and even cause blackouts. The sky over John's head is darkening and turning ominously green. Something hits him on the forehead. Ouch! He picks up the offending object. It's a hailstone, but it's not that cold outside, and it's not raining. Soon, he hears some noise. It's approaching rapidly and turns into a loud roar. It sounds as if a freight train is moving towards him, but it's not a train. It's a tornado. The funnel isn't visible behind a cloud of debris, but John can't mistake this rotating column of air for anything else. Are you on the road, John? Then get as far away from your car as you can. Fast! Find a ditch, lie down in it, and cover your head. Oh, you're inside? Then get away from the windows and hide underground if possible. And please, John, be very careful if you spot some conically shaped clouds. Those mean severe storms. And if you notice that such a cloud starts spinning around, immediately search for shelter. The cloud is transitioning into a tornado right in front of your eyes. On the bright side, John should only worry about warm conical clouds. Cold ones are totally harmless. The only problem is to figure out the temperature of the cloud he sees. Duh! Ah, look, John just spotted some weirdly shaped trees. They look like the letter J and grow on a slope. It means the ground under John's feet is likely to be unstable. If he keeps wandering around, it can cause a bad landslide. Square waves appear when two different wave patterns crash into each other. This phenomenon does look kinda awesome. No, don't go into the water, John. Keep watching it from the shore. Cross currents in that spot can easily pull even a skilled swimmer under the surface. John keeps walking along the shore. At one point, he sees wild, choppy waves carrying ocean debris and seaweed. This time, he stays out of the water. He knows it can be a sign of a strong rip current. It can carry a swimmer far away into the ocean. How about a walk in the park? John likes this idea. The sun is shining and the sky is so blue and beautiful. Suddenly, he spots a rapidly growing vertical cloud. At first, it looks bright white. But as it approaches, alarmingly fast, it becomes dense and inky. The sky is darkening. It's getting windy. That's when the guy notices that his hair stands on end. It's his cue that he's about to get hit by lightning. At this very moment, positive charges are rising through his body. They're reaching towards the negatively charged part of the storm. If he doesn't react fast, these charges will meet. There's nowhere to hide, so John should crouch down and try to make himself smaller than the objects around him. Oh no, John, don't lie down on the ground. It may be damp and thus a great conductor of electricity. There are other signs that scream danger during a lightning storm. John's palms may begin to sweat. He might hear bizarre crackling and buzzing sounds coming from metal objects nearby. His skin can start tingling. There might be a strange metallic taste in his mouth. Plus, John is likely to smell chlorine. That's how ozone smells. Electrical charges split the molecules of nitrogen and oxygen, which are the main gases making up the atmosphere, into separate atoms. When these atoms come together again, some of them produce molecules made up of 3 oxygen atoms. That's ozone. We can smell it during a thunderstorm because downdrafts bring this gas from high altitudes to your level. Some bugs can feel a storm coming. They get ready for a natural disaster by freezing. So, when John notices that insects around him look drowsy, he knows to get ready. Oh, and bees can predict heavy rainstorms. These critters begin to work much harder the day before it starts raining. While walking next to the river during a period of heavy rains, John hears a roaring sound. He feels paralyzed with fear. It's likely to be a flash flood moving in his direction. Indeed, he soon sees debris coming down with the flow. The water is rapidly changing its color, becoming muddier and darker. Flash floods are very, very dangerous. Take care of your safety immediately, John. Another day, John sees a spectacular wall cloud. It seems to be stretching for up to 5 miles. In the best case scenario, it's just a severe storm coming. But if the wall cloud begins to move in a circle, it's a sure sign of a tornado. John is walking across a snowfield in the mountains, listening to the sounds the ice under his feet makes. The noise is kinda hollow. Quickly check whether there are cracks around your footprints, John. If so, the chances are an avalanche is about to happen. Soon, John sees an avalanche moving in his direction. He does his best to get off the slope. In most cases, he could probably outrun it by heading downhill and then veering sideways, but not this time. He realizes he doesn't have enough time and heads for the nearest tree. If John keeps holding on to it really tightly, the avalanche might not pull him along. But if this doesn't work, he should try to swim up to the snow's surface while the avalanche is still moving. On a pretty nice summer evening, John notices leaves with soft stems droop all of a sudden. It might be because of an upcoming storm. Right before extreme weather arrives, the air usually becomes more humid. Leaves also get damp and heavy. and the wind easily flips them over. John lives in a pretty old house and is used to having cracks in the interior walls, but one day, he notices that some of them have widened, and look, there are a few new ones. It's an alarm bell. He lives in an area with loads of limestone, so new cracks can mean a sinkhole is about to open next to his house. John is hurrying home, trying not to waste time admiring shelf clouds. They look like something from a sci-fi movie. They form when warm and moist air gets caught in a thunderstorm updraft, and these ominous clouds most often mean a storm is coming.
Asteroids are a serious, very real danger. Some of them are big enough to cause a lot of trouble if they collide with Earth. One asteroid in particular is making headlines these days. A new study has revealed there's a small chance it could hit our planet during its close flyby in 2029. But the question is unusual. Will the asteroid survive this encounter? Apophis, which got its name from Apep, the Egyptian deity of chaos and disorder, has become one of the most infamous asteroids. Discovered in 2004, this space object is about 1,100 feet wide. It's about the height of the Eiffel Tower in Paris. Because of its size and the close flyby predicted for 2029, astronomers classify Apophis as a potentially hazardous object. Those are asteroids and other space objects that pass close to Earth and are big enough that we really need to pay attention to them. Right now, scientists say the chances of a collision are slim, less than 1 in a billion. So, at the moment, we can probably claim that Earth is out of danger. But the same can't be said about the asteroid itself. When Apophis passes close to Earth in 2029, our planet's gravity is likely to shake it so violently that it may experience something like an earthquake, a cosmic asteroid quake, if you will. The stress from this gravitational force will probably cause parts of the asteroid's surface to crack off and fly into space. And even though this might not be a full-blown disaster, and the asteroid won't fall apart completely, it's very likely to lose some material during the flyby. Some of this debris might just stick around in orbit, while other bits could fly off into deep space. Over time, this catastrophe could affect Apophis's rotation, causing it to spin differently or tilt in a way it hasn't before. And this is a phenomenon scientists are really interested in, because it could teach us a lot about how asteroids react when powerful gravity is pulling on them. Now, let's get back to Earth. Well, we haven't left. Anyway, even though the asteroid isn't big enough to wipe out the planet like the asteroid that destroyed the dinosaurs, it's large enough to cause serious damage to a large city if it ever collided with Earth. It could mess with the climate all over the planet, too. At the moment, it looks like the space rock will sail past Earth at a distance of around 20,000 miles. It's still worryingly close, but far enough to avoid a collision. To put it in perspective, that's less than a tenth of the distance between Earth and the Moon. So while Apophis likely won't hit us, this flyby could still cause problems for some of the satellites orbiting Earth. They will be much closer to Apophis than we are. The key point is that we can't rule out a risk of a collision in a few more years. As Apophis gets closer, astronomers will keep a very close eye on its trajectory to make sure it doesn't veer off course due to the influence of Earth's gravity. In fact, this gravitational pull could actually cause some serious changes to the asteroid itself. Now, even though Apophis is not likely to cause a global disaster if it were to hit Earth, the consequences would still be pretty severe. The impact could destroy an entire city, and the resulting climate changes could mess with food production for years. It wouldn't be an extinction-level event, but it would still be a huge deal. Now, Apophis is not the only asteroid we need to worry about. Scientists are constantly on the lookout for other asteroids that could potentially cause harm to our planet. Thanks to new technology, astronomers can now track dangerous space rocks from way farther out in space. One cool new method they're using involves studying meteor showers. These showers are actually caused by long-period comets that have been orbiting the Sun for hundreds or even thousands of years. As these comets pass by, they leave a trail of dust and debris, which can end up creating meteor showers when Earth passes through them. Scientists analyze the properties of meteor showers, like their speed, direction, and where they come from. This can help them trace the particles back to their parent comet or asteroid. It's actually a big deal, because it means we might be able to spot potentially hazardous asteroids long before they get close to Earth. The upcoming Legacy Survey of Space and Time project, which is being run out of the Vera Rubin Observatory in Chile, is going to help astronomers track these space rocks from even farther away. Astronomers are going to create a detailed map of the sky and the regions where meteor showers are most likely to occur. It'll help them predict which asteroids might become a problem for Earth in the future, giving us plenty of time to prepare or come up with a plan. But even now, there are many space rocks that can potentially cause a lot of trouble to our planet. Let's look at some of them. Here's the asteroid Bennu. Astronomers discovered it in 1999. This carbon-rich rock is about 1,600 feet across. It's the height of the Shanghai World Financial Center. Didn't you know that? At the moment, this asteroid is the greatest threat to Earth that we're aware of. But don't panic yet. The collision won't happen for a long time. In fact, scientists calculate a 0.037% chance, which is about 1 in 2,700, of Bennu striking Earth on September 24, 2182. I won't be around then. If Bennu does hit our planet, the impact would release so much energy that it would be enough to cause massive destruction in a large region. But luckily, it wouldn't wipe out the entire planet. Still, if Bennu hit a city, the consequences could be catastrophic. NASA's OSIRIS-REx spacecraft has recently visited Bennu and returned with samples, so scientists are learning more about this asteroid all the time. The next asteroid is another one to keep an eye on. It was first discovered in 1950, but wasn't seen again until 2000. Right now, scientists say there's a very slim chance, 1 in 34,500, that it could hit Earth on March 16, 2880, 800 years into the future. So, am I worried? Nah. If it did strike, it would release so much energy it could lead to a global catastrophe, potentially wiping out humanity. Or not. Our next asteroid has been discovered only recently. It was spotted in October 2023. It has a very low chance of striking Earth on October 10, 2119. Man, they got it down to the day? Now, if it were to collide with our planet, the impact would release a lot of energy, which would have a devastating effect for large areas. So, while the arrival of this asteroid is a long shot, this asteroid is still worth keeping an eye on. Now, this asteroid is known as a lost asteroid because it hasn't been seen since 2007. No wonder, it has a very uncertain orbit, and we can't predict its movements. NASA says there's a tiny chance, about 1 in 10 million, that it could strike Earth on March 3, 2030. If it did, the energy released would be able to cause huge regional damage. Finally, we've got this space wanderer. On the one hand, it hasn't been seen since 1979. On the other, scientists believe that there's a very low chance that it could hit Earth on December 14, 2113. Mark your calendars. If it did, the impact would cause a lot of damage and devastation, but it would not lead to the end of humanity. Now, in any case, even though the chances of an asteroid hitting Earth are low, the consequences of such an event could be huge. That's why scientists are so focused on studying these space rocks and tracking their movements. Thanks to new technologies, we can track dangerous objects from farther away and catch them earlier. It can give us more time to react and come up with some effective solutions.
That tiny dot in the sky is an asteroid called 2024 YR4, and it gave scientists a serious scare. Early projections showed a 2.3% chance that it could hit Earth. That might sound small, but for an object big enough to wipe out a city, it was enough to raise alarms. Now, there's good news and bad news. The good, it's no longer on a collision course with our planet. The bad, it might be heading for the moon instead. Astronomers first spotted it in the El Sos Observatory in Chile, back in December 2024. Judging by how bright it appeared, they estimated its size to be somewhere between 130 and 300 feet wide. That's about the size of a football field. If something this big hit Earth, it could be truly catastrophic. I mean, not on the level of the asteroid that wiped out the dinosaurs, but still enough to destroy an entire city, depending on where it lands. Drop it over Paris, London, or New York, and you're looking at complete devastation across the city and nearby areas. That's why it was considered one of the most dangerous space rocks to ever come near us. It makes total sense that this asteroid became a bit of a celebrity. From the moment it was discovered up until February 2025, the risk of a collision just kept climbing. But now we can breathe a little easier. New calculations from NASA have completely ruled out any chance of impact. In fact, there's no serious threat from this asteroid for at least the next 100 years. Okay, but how did we go from this is a threat to, oops, we were wrong? That happens quite often, actually. I mean, an asteroid seems risky at first, then it gets even riskier, and then, out of nowhere, it's suddenly safe. Does that mean we can't trust their math? You see, the first time specialists spot an asteroid, it's really just a tiny dot of light in the sky. At that point, they have no idea what it is or where it's headed. Then they have to observe it again and do some math. That will help them figure out the path they're moving on. But even then, it's still a bit uncertain. They don't really know where the asteroid is going, so the risk corridor is this huge area where it could fly through. If any part of that corridor crosses Earth, the asteroid is considered a threat. Usually, at least 3 observations are needed to figure out its orbit. Basically, how fast it's moving and where it's headed. A lot of times, as they start to get a clearer picture, the risk zone still overlaps with Earth, so it looks more dangerous at first. But typically, as they keep tracking it, the risk zone gets smaller and moves away from Earth, and suddenly, the risk drops. And they keep narrowing down the uncertainties until they can confidently say, "Relax, y'all, it's not heading for Earth." And that's exactly what happened to just our famous 2024 YR4. So, we can all relax a bit now, right? Yeah, we know that 2024 YR4 won't hit us, but it could end up crashing into the moon instead. At first, projections said there was a 1.7% chance of that happening in 2032, but recently, that number has gone up a little to 3.8%. If it does hit the moon, though, it won't be dangerous for us. I mean, there won't be any shockwaves felt here on Earth, and the moon isn't gonna crack in half. Experts say nothing really shocking or concerning would happen, but it would be an awesome opportunity to see a lunar impact. If we're lucky, we might even catch the exact moment it happens. And if we miss it, we will still get to observe a brand new crater on our natural satellite. Such events are pretty common for the moon, since it doesn't have an atmosphere to protect it from incoming debris. In fact, there are hundreds of detectable impacts each year. See those bright spots lighting up? These are real images of asteroids hitting the moon. But specialists aren't just sitting around and waiting. They've been keeping an eye on lunar impacts for years. For example, the European Space Agency has a project called Neliota, where they use a powerful telescope in Greece to track these impacts. They've recorded over 100 tiny explosions from space rocks hitting the moon. They also have the Lumio mission, which is a small satellite that counts lunar impact flashes on the far side of the moon, the side we can't see from Earth. These observations help scientists understand how often the moon gets hit and how this might affect astronauts and lunar bases. Now, 2024 YR4 might be a special case. That's because most space objects that collide with the moon are really small. We've never seen a collision with something larger than about 160 feet. If YR4 does hit, it could be an amazing sight. So yeah, scientists are kinda hoping it happens. But 2024 YR4 isn't the only asteroid on the radar. There are actually quite a few others that have been classified as potentially hazardous. In simple terms, that means this one might cause us some trouble. You see, there are millions of big space rocks out there in the solar system, mostly chilling in the asteroid belt between Mars and Jupiter. But only a few ever get close to Earth, and even fewer actually pose any real risk. NASA calls asteroids that orbit within 30 million miles of Earth near-Earth objects, and within that group, there's a smaller bunch of really big ones that orbit super close to us. If one of those were to hit us, it could be a big deal. There are about 2,500 of those asteroids at least that we know of. But here's the good news. Specialists don't expect any of them to hit Earth anytime soon. A few might come pretty close though, or already have, like the 2014 TN17, an asteroid that's about 540 feet wide. It got pretty close to us in March 2025, zipping by just 3.2 million miles from Earth. That's roughly 13 times further than the Moon. So yeah, not exactly close, right? But when you think about the vastness of the universe, it's actually kind of near. In fact, that was the closest this asteroid has come to Earth in nearly 300 years. Thankfully, nothing happened, and that asteroid has already drifted away from Earth again. But it's not like you need to lose sleep over asteroids that could hit our planet. Little asteroids enter Earth's atmosphere every single day. It's the big ones we worry about, like the ones you see in Hollywood movies, like Armageddon. But asteroids like that are being constantly monitored. All the objects we know of today have 0 or 1 chance of impacting Earth. And if things change, there are a few strategies that could be used to save humanity from an impact. Take the DART mission, for example, which happened in 2022. This was NASA's first test of planetary defense. They successfully managed to deflect an asteroid off its course using a spacecraft. In this case, the asteroid didn't pose any threat to Earth, but it was the perfect test subject. There are also more experimental ideas out there. For example, lasers could vaporize part of an asteroid to create a thrust effect, pushing it off course. Another idea is the gravity tractor, a big spacecraft that slowly tugs the asteroid away using its own gravitational pull. But all of these are still just ideas for now. If we can't pull any of those off, authorities would probably still have enough time to evacuate the impact zones. So yeah, I wouldn't stress too much about an asteroid impact. Back in the day, from 774 to 775, Earth got hit with a mega blast of radiation. This crazy burst of energy left its mark. 3 rings from that year show way too high levels of radioactive stuff. But what exactly caused it? Scientists are inclined to think that the reason was a solar flare. Some folks think maybe a massive supernova caused the radiation blast. But astronomer Phil Plait says that if that had been the case, it would have had to be less than 1,000 light years away and would have had been crazy bright. But there's no record of that happening. No bright, shiny Death Star in sight. After looking at the radioactive carbon and beryllium in tree rings, scientists ruled out a bunch of other possibilities. At first, they considered that it was a smash-up between neutron stars or a neutron star and a black hole. These types of crashes produce a super quick blast of gamma rays without any light show, which lines up best with the evidence. But these kinds of collisions are super rare. Plait thinks it's kinda unlikely that this is the answer. He figures we should only see one of these events in our galaxy about once every million years. So having one just 1,200 years ago seems pretty wild. Scientists are seriously worried about these rare events. If one happened closer to Earth, it could seriously mess up life on our planet. Even if it was thousands of light years away, a similar event today could cause chaos with all the fancy electronic systems we've come to rely on. So it's a good thing those gamma ray bursts are so rare, because if they were more common, Earth might be in for a rough ride. You may think that if our planet could withstand mega radiation blasts, it can easily withstand something less frightening. Let's say grasshoppers. Sorry to say that, but it's not exactly true. Back in 1874, during a hot summer in Kansas, things took a strange turn. Grasshoppers, or should I say locusts, invaded the Great Plains like nobody's business. They came down like a storm, blanketing houses, trees, and even poor trains passing by. These bugs were on a mission to cause chaos. Farmers had to scramble to protect their wells and just about anything else worth saving. Locusts landed everywhere, wreaking havoc on everything in sight. Even poor sheep lost their wool. Locusts even stripped paint off wagons and handles off pitchforks. This is how destructive they were. Livestock tried to fight back by eating them, but there were just too many of these insects. That year, those critters caused about $200 million in crop damage. The locust invasion was so tough, even the US Army stepped in to help. In the end, locusts began to disappear, sparing the plains from further devastation. Natural disasters can be even more unexpected than radiation blasts from space and locust invasions. Check this out. Back in June 2017, a reindeer herder up in northwest Siberia was minding their own business when they suddenly heard a crazy loud blast and saw smoke shooting up from the ground. If that happened to me, I'd need to change my pants. Sorry. Later on, they found this huge hole that was like 23 feet wide and nearly 65 feet deep and was surrounded by chunks of ice and dirt. It turned out that there were over 17 such black holes in the area. They were filled with peaty water and shrouded in mystery. Some folks thought those were sinkholes. Others were sure they were left by top-secret device tests or even a bunch of meteorites. Now, the latest idea is that these holes are actually craters caused by the Arctic warming up and melting the frozen ground. The theory states that as the ground thaws, gas pockets trapped beneath the surface burst through, creating such dramatic holes. Apparently, these eerie craters have been showing up in specific spots in Siberia where ancient geological faults have been leaking out hot natural gas for ages. Combine that with some leftover methane from old lake sediments, and you've got a recipe for some explosive surprises as the planet heats up. Not scared yet? All right, maybe you're afraid of darkness, huh? If so, you wouldn't like it back in 536. It's the year when the world went through a crazy 18-month period of darkness. A mysterious fog covered Europe, the Middle East, and parts of Asia, blocking out the sun and causing chaos. It was like the Dark Ages, but for real. It turns out that the main culprit behind this fog was a volcanic eruption in Iceland. This eruption spread ash across the northern hemisphere, causing temperatures to drop and crops to fail. People were freezing and starving. It was a mess. Historians from back in the day even talked about how weird it was. The sun looked like the moon, summers were freezing cold, and even China had summer snow. It was all because of the volcanic ash blocking out the sun. And to make things even worse, this period of darkness sparked the beginning of the bubonic plague in 541. Talk about a rough time to be alive. Let's go back to Siberia real quick. Back in 1908, way out in the wilds of Siberia, an asteroid dropped for an unexpected visit. Today, we know it as the Tunguska asteroid, but it didn't get its name instantly. Local folks only caught a glimpse of the show. A bright fireball streaking across the sky, followed by a massive boom. Trees went flying, fires blazed, and animals weren't too happy about it either. But since the area was so remote, not many folks took notice. For almost 2 decades, nobody bothered to check out the Tunguska site. People had too much on their plates back then. But then, scientists finally made it out there and found evidence of the asteroid's shenanigans. Later in expeditions, they found some spacey microparticles. Fast forward to now, and NASA has a whole planetary defense thing going on. They even sent a mission to test out asteroid deflecting tech. Because who knows when the next cosmic rock will come knocking on our door, right? In the middle of the 19th century, there was one more epic solar storm called the Carrington Event. It may not sound like a big deal to you, but it had pretty rough consequences. The next day after the storm, Earth was hit with this insane geomagnetic storm that threw telegraphs off the rails and brought auroras to the tropics. And it's the place where they normally never show up. Turns out, all this space weather madness started with weird stuff happening on the sun's surface, like sunspots. From these spots, solar flares and other crazy electromagnetic stuff can pop out and mess with our technology. Massive solar storms like this one can shoot out from the sun at speeds of up to 1,800 miles per second. They can contain billions of tons of solar material, complete with a sassy little magnetic field that loves to mess with Earth's magnetic field when they meet. Now, listen closely. We're getting close to the next solar maximum in 2025, so it's a good time to check out the history of the worst solar storms, like the Carrington event, and take notice. Imagine if a similar storm hit today. An internet apocalypse, anyone? Businesses would be sent offline and we'd be facing some serious damages. Luckily, these mega solar storms don't happen very often. But hey, space weather is tricky to predict, so who knows when the next one will hit?
So yeah, a giant asteroid fell to Earth and destroyed all dinosaurs with a blast wave. That's what we've all heard. It was a terrible disaster, but it was actually much worse. You can't even imagine how unfortunate it was for dinosaurs and what kind of disaster they faced. It wasn't just a piece of solid rock from space, but a lump of molten clay. It provoked not just a tsunami, but giant mud waves. It filled the atmosphere, not only with a burnt smell, but also with an acidic and foul smell of rotten eggs. It didn't just sweep everything away with a blast wave. It provoked a volcanic winter, poisoned the air, and blocked the sun. And do you know what the most unfortunate thing was? If the angle of the fall had been just a little bit different, or if it had fallen a little further away, then there might not have been any global catastrophe. That asteroid, the size of Mount Everest, fell in the coastal part of the Yucatan Peninsula. This place separates the Gulf of Mexico from the Caribbean Sea. The asteroid touched both solid rock and water and immediately triggered strong tsunamis and mega ripples. These are large sand waves that are normally about 3 feet long on average and leave a pattern similar to dunes on the seabed. Oh, by the way, they're really called subaqueous dunes. So, when the meteorite fell, it formed 52-foot-high mega ripples. Can you imagine? Giant waves of sea mud that are almost as high as a 5-story building. But how did the scientists figure it out? They used 3D seismic data and modeled the mega ripples pattern in the program. The data was based on the landscape of the bottom, which was impacted 66 million years ago. First, a powerful strike triggered a strong earthquake that liquefied the seabed layer, and then a high-grade tsunami triggered those mega ripples. That is, while giant waves on the surface flooded the land and went into open waters, large mud waves destroyed the seabed. Ancient fish, dinosaurs, and other underwater creatures didn't stand a chance. But what does this information tell us? Well, first, studying the effects of ancient tsunamis helps to reconstruct the past of our planet. Secondly, it helps us to be prepared if something like this happens in the future. Predicting a scenario like this could save countless lives in case of danger. Okay, there was a total mess in the water at the time of impact. But what was happening on land was much worse and scarier. But let's discuss the meteorite itself first and what it consisted of. The scientists analyzed the rocks at the impact site and saw traces of carbonaceous chondrites. This is the rock that makes up most of the meteorites in space. Often this rock contains water, clay, and organic compounds with carbon. It means that, in a sense, a lump of dirt the size of the highest mountain on the planet fell on Earth. And yes, carbonaceous chondrites often have an unusual smell of rotten eggs, tar, or wet hay. So it wasn't just very loud, but it also probably smelled bad. It was a fetid rocket on a planetary scale. However, at the time of the fall, not a single living creature was there to sniff it. All of them lost their lives in the first seconds of the disaster, hit by the devastating blast wave. It set a chain of events that later wiped out all the dinosaurs from the face of the Earth. The peninsula where the meteorite fell turned into a large crater in an instant. Thousands of tons of soot and ash were released into the air. A huge area was filled with thick smoke. The sky turned gray. Black clouds obscured the sun. But wait, where did the ashes come from? The crash site contained huge reserves of flammable materials. In simple words, the meteorite fell into a giant barrel of fuel which started to burn. The sky remained dark. Grass, plants, trees, and bacteria couldn't get enough sunlight. The green world began to wither. And this affected not only the impact site, but almost the entire continent. Even dinosaurs, living far away, felt the low temperatures and lack of ultraviolet light. Dinosaurs couldn't survive in such conditions. The environment was changing too fast. Then it got even worse. A firestorm was spreading in all directions from the place where the meteorite had fallen. The air inside the storm was poisonous and dangerous to inhale. And you know why? Because the meteorite fell in a coastal area and destroyed the seabed. And under that seabed, there were large reserves of sulfur. This toxic mass rose into the air mixed with ash, soot, red-hot pieces of rock, and meteorite particles. Then the winds picked up this cloud and began to spread it across the continent. The rainforests that survived the blast waves were still in danger, as the hot toxic cloud rained down red-hot ash upon them. This caused large-scale fires. The smoke from the burning trees rose and became part of the destructive cloud. The more trees burned, the larger and thicker the poisonous ash cloud grew. What could have stopped this catastrophe? Rain clouds filled with water, right? Good point, but they didn't. When the hot ash and sulfur fumes mixed with water, they created acid rain, a downpour of poisonous, corrosive mud that wiped out all life around it. Fires, firestorm, acid rain, sun blockage – how could dinosaurs survive after that? Where could they escape? Perhaps the ocean shore? Bad idea. Yeah, the water could have protected them from the fire and ashes, but there was another problem. Do you remember mega ripples and giant tsunamis? A huge wave that hit the shore at that moment could easily wash away New York. Smaller waves rolled across the Atlantic Ocean and the North Pacific. So, if dinosaurs on land had tried to hide near the shore, they would have been swept away like specks of dust by that giant tsunami. But what about underwater dinosaurs? They were not affected by the tsunami and the fire cloud, but they were trapped. Red-hot poison particles of ash and mud fell into the ocean in huge quantities and poisoned the water. Algae and phytoplankton were destroyed. Because of this, millions of fish lost their food supply. And as a result, larger fish and marine dinosaurs were left with nothing to eat. Large-scale famine triggered extinction in the ocean. Toxic particles poisoned the water for many marine life forms. The gills of fish couldn't extract pure oxygen from the water, which only worsened the situation. Near the Yucatan Peninsula, the ocean floor with its coral reefs and ancient sea creatures was destroyed. This huge part of Earth's biodiversity disappeared, upsetting the balance of the oceans. Of course, the destruction couldn't go on forever. At one point, the ashes cooled and settled to the ground. The sulfur cloud dispersed, the fires went out, and the air became clearer. Warm rays of sunlight began to shine down on Earth again. But there was something sinister about the silence. The planet no longer heard the rustle of pterodactyl wings, the roar of a hungry tyrannosaurus, and the noise of a velociraptor's fast feet. The storm had passed, along with the dinosaurs. By the way, some flying lizards and small animals survived. Later, they evolved into modern mammals and birds. It wasn't the meteorite that destroyed dinosaurs. Fires couldn't do it either. Dinosaurs disappeared because of the famine caused by the catastrophe. Disruption of the food chain led to the mass extinction of these magnificent lizards. After the catastrophe, life began to blossom again. However, the emergence of large mammals was still a long way off. But now, millions of years have passed. Large elephants, rhinos, and other animals walk on Earth, along with the most unique mammal on the planet, the human.
Asteroids aren't as rare on our planet as we may think. About 17,000 of them visit us every year. You've probably seen at least one in your life. For example, if you've seen a shooting star. They leave these bright tails behind them as they pass through Earth's atmosphere. Of course, they only look beautiful in the sky. If they reach the ground, the consequences would be catastrophic. Luckily for us, most of them explode 30 to 50 miles above the surface. Their mass is too small for them to withstand such a journey to the end, so most of them remain harmless to us. But we shouldn't underestimate them. Let's start with the smallest ones. 1 to 3 foot high asteroids are about the size of a person. They're too small to cause any real damage. Most often they explode in the atmosphere without even reaching its lower layers. But at the same time, they splash up tons of energy over the surface every time. 13 to 15 foot asteroids, the height of giraffes and mammoths. These larger meteorites come to us less often, once a year and a half. Like the previous ones, they, fortunately, don't pose a serious threat, but they splash out much more energy. 30 feet, the height of a 3 to 4 story building. They visit us once every 10 years, and now we're talking seriously. It throws out a wave that could demolish an entire city. I think you understand how catastrophic the consequences would be if this asteroid touched Earth. 65 feet, multi-story building. They like to visit Earth once every 60 to 70 years. Good news, it explodes at 12 miles above the ground. Its released energy could destroy an entire region if it touched the ground. Bad news, such an asteroid has already visited us recently, and the consequences were pretty rough. It all happened in a city called Chelyabinsk. On February 15, 2013, at about 9:20 a.m. local time, the giant slowed down in the Earth's atmosphere and then broke up into small pieces at 14.5 miles above the Earth. These pieces then flew in different directions. It shattered the windows all over the city and damaged many buildings, including people's houses, schools, and others. It took a while to repair everything, and the scale of this destruction was quite serious. As a result, there were 1,615 injured. But fortunately, no casualties. At least we're safe for the time being. The next such asteroid may come to us only in the 2070s or 80s, and no one knows where exactly it wants to land. Now let's move on. 300 feet. This is the height of the Statue of Liberty together with the pedestal. Such a giant can be seen every 4,500 years, and this is the first asteroid on our list that may literally crash into Earth. The consequences are disastrous. Not only may it demolish an entire city, but it can also set fire to neighboring areas. Well, some people even witnessed such a meteorite land on our planet. The notorious Tunguska meteorite is the biggest asteroid disaster that people have ever seen. It all happened on June 30th, 1908 in eastern Siberia. The meteorite was bright, like a second sun, and people felt the heat wave when it just approached the Earth. It exploded near the river. Fortunately, the whole area was surrounded by taiga, and there were no big cities nearby. But even there, it immediately destroyed a lot of trees. Serious forest fires broke out. The sound of the explosion was heard by people hundreds of miles around. At tens of miles around, all the houses' windows broke. The magnetic storm that resulted from this collision lasted 5 hours. The consequences were truly disastrous, but perhaps this is not the worst thing that awaits humankind. 99942 Apophis, 1,215 feet. It's slightly bigger than the Eiffel Tower. This meteorite, as scientists discovered in 2013, will be our next guest. Collisions of such force occur in about 100,000 years, and this one is gradually approaching. The force of such an explosion is equal to the force of the catastrophic eruption of the Krakatoa volcano in 1883. This eruption is considered one of the most destructive in history. It caused a terrible tsunami. 165 cities and settlements were completely destroyed, and another 132 were seriously damaged. People all around the globe could feel the consequences of this eruption, at least to some degree. Such an asteroid could leave a 3.5-mile crater, and this is one we'll face in the distant future. But calm down, no need to panic yet. By 2070, the meteorite will be almost 174 million miles away from us. It still has a very long journey ahead of it, so we're safe for at least 100 years, or even more. Besides, our planet has survived something even worse. 3,280 feet. This is higher than the tallest tower in the world, the Dubai Burj Khalifa Tower. Such collisions occur once every 500,000 years. We're not sure when such a collision occurred the last time. 70% of our planet is covered with water. If such meteorites fell into the ocean, it would be extremely difficult to find their traces. But we can assume the possible consequences. The wave would have swept across the entire hemisphere. The crater would be about 9 miles in diameter, and that would be a complete disaster. The last event of such a force happened 26 to 28 million years ago. It was an eruption of the supervolcano La Garita, which is located in the southwest of Colorado, USA. It was one of the most powerful known supervolcanic phenomena in history. During this monstrous eruption, a significant part of the current state of Colorado was destroyed. Scientists are still not sure how far the ashes have spread, but there was an even bigger meteorite in the history of mankind. The consequences of that impact were irreversible for an entire species of animals. I think you know what I'm talking about. Chicxulub meteorite, the thing that wiped the dinosaurs off the face of the Earth. This happened about 66 million years ago. These collisions in general happen about every 500 million years. The height of the Chicxulub meteorite was 12.4 miles. It's so high that when it touched the ground, it could reach the stratosphere. Even looking at the 124-mile diameter crater left by this meteorite, you can understand how huge it was. When it collided with the Earth, millions of tons of energy were released. This is an unimaginable disaster. It fell at a very steep angle, creating a giant cloud of dust and chemicals that spread around the world. This dust had a very thin layer, but also a mass of 50 trillion tons. The shockwave swept across the entire planet. It caused several earthquakes. Volcanoes began to erupt actively. Forest fires broke out everywhere, all over the world. The amount of soot and carbon dioxide released into the atmosphere is invaluable. The Earth was closed from the sun for several days. Darkness reigned all over the planet. Planets couldn't produce enough oxygen, so there was nothing to breathe. The temperature on the continents and in the oceans dropped by an average of 50 to 90 degrees Fahrenheit. Sounds horrific, doesn't it? And of course, it caused one of the greatest extinctions in the history of the Earth's biosphere. Amazingly, the Earth was able to recover after such a catastrophe. This event became the boundary between the Mesozoic and the Cenozoic eras. So now, those who wondered, how could a small meteorite destroy all the dinosaurs, probably understand the answer. Perhaps the largest collision in the history of our entire planet was not a collision with a meteorite, but with an entire planet. This happened many, many billions of years ago. Theia, as this hypothetical dwarf planet was called, crashed into our Earth, releasing an incommensurable amount of energy, just quadrillions of fuel. The Earth then instantly turned into a giant fire, and it was this collision that led to the creation of the Moon. All that sounds terrifying, I know, so let's just hope that you and I will never see anything like this.
Are you sure that it was an asteroid that caused the extinction of dinosaurs? There's this huge drama about why these horrifying creatures disappeared. It's a big deal in both science and movies. But what really happened to the dinos? How do scientists figure it out? And why does it even matter? Let's see. Let's take a trip back to England in 1842. There was a scientist named Sir Richard Owen. He was checking out some huge reptile fossils and noticed that 3 of them, Megalosaurus, Iguanodon, and Hylaeosaurus, had a lot in common. So he had this light bulb moment and decided to combine all these creatures into Dinosauria, which means terrible lizards in Greek. The scientists were studying dinosaurs and grouping them based on their looks. But then Charles Darwin showed up and gave even a better idea. Turns out, species don't just appear out of thin air, they evolve. And now, everyone had to rethink how they were defining dinosaurs. They came up with a new idea called phylogenetic classification. Picture a big family tree with all creatures ever. Somewhere up there, we find Megalosaurus and Iguanodon, and we say all dino descendants come from their common ancestor. It's like tracing back your family tree, and if we go far enough, we find the ultimate dino ancestor. Sounds like a plan. But then, things got a bit complicated. When we talk about dinos, we've got the ones with feathers and beaks and the ones without. That's when we found out that birds are cousins to certain dinosaurs, maybe even evolved from them. After learning that, Scientists had to look at the bird family tree and rethink the dino definition. In the end, they decided that birds are kinda dinosaurs, but not exactly. Confusing, huh? But in any case, now we have two groups. The first one is birds, and the other one is non-avian dinosaurs, which are extinct. That means now we have to reconsider our question. Instead of asking what caused the extinction of dinosaurs, it should be what caused the extinction of non-bird dinos. The answer might seem simple. People often think of a gigantic space rock as the dino destroyer. It's probably the first thing that pops into your mind. Even Google and other search engines agree on this one, like best friends copying each other's homework. History teaches us that about 66 million years ago, dinosaurs totally vanished, except for the ones that became birds. Of course, the truth is more complicated. And not all dinos vanished in one go. Some went the natural way, and there were many extinctions here and there during their time on Earth. But the big event we're talking about looks like a movie scene change. Like suddenly changing the channel on a TV. One poof. And the Earth went from the time of dinosaurs to the time of mammals. Scientists call these time periods the Cretaceous and Paleogene. We even give this special event a nickname, the KPG, or KT extinction. Some even refer to it as the 65 million years ago event, even though the more correct number is 66 million years ago. We've got two main theories in the spotlight: asteroids crashing and volcanoes erupting like crazy. Let's talk about the asteroid idea. So, around 66 million years back, imagine a humongous asteroid smacking into Earth. This thing was about 6 miles wide, about as big as Mount Everest. It zoomed through the sky super fast, like a mountain going 100 times the speed of sound. And when it hit, it released a ton of energy. It crashed down in what's now southern Mexico, near a spot that's tied to the dinosaur extinction story, Chicxulub Crater. Everything close to the impact was zapped into vapor in a snap. Picture the biggest energy burst in ages, like 1 billion years or more. Nothing near the crash site stood a chance. Next, there was the aftershock. As the fireball cooled down, the Earth's surface went bonkers. The ground twisted and shook, causing unimaginable earthquakes. The continents became huge, bouncy castles. And then, the stuff that got blasted up by the impact came raining back down like a rainstorm. Even if you weren't near the huge pieces falling in Mexico, you'd get hit by these smaller, super hot bits flying through the air. This made the air so toasty that forests burst into flames all around the world. Are you ready for more? Time for a massive tsunami. The ocean floor got all churned up, pushing waves inland around the Gulf of Mexico. But just imagine, even all that wasn't enough to destroy all the dinosaurs. For example, dinos in New Zealand were pretty fine, but we know that they all went extinct. So what happened to them? They felt a little rumble, and suddenly, the sky started getting all dark and gloomy, as if it was nighttime. And hold up, what's that? A blanket of ash is slowly creeping around the whole planet. Now, here's where the real drama happens. The big problem with the asteroid crash wasn't the instant boom you might think. It's all about the long-term effects. Imagine the stuff that got blasted up into the sky blocking the sunlight. Days turn into nights, and temperatures drop very sharply. A lot of plant-eating dinosaurs passed away, and hunters were having a great feast, but not for too long. Without sunshine, the food chain falls apart very quickly. Then, the ash falls back to Earth. Things go from bad to worse. Other nasty stuff starts floating around in the air like carbon dioxide. This carbon dioxide mixed with shattered seafloor bits makes the temperature go wild. The Earth was playing hot and cold all at once. That's when somewhere between 50 and 80% of dinosaurs said goodbye forever. What's even more sad is that this number only counts the species themselves. If we look at the number of individual animal lives lost, it's even higher. You might think that at least the poor mammals finally got their chance after the dinos left. But even mammals had a tough time. We are very lucky that a few brave mammals managed to survive this crazy chaos. The ones who made it were like the little champs with speedy energy systems, flexible diets, or secret hideouts. But this story is only one hypothesis. Next, we have the volcanism hypothesis. Volcanoes. These fiery mountains are used to spitting out molten rock and causing epic destruction. But surprisingly, this theory isn't about explosive eruptions. Nope. It's about something sneakier and slower. Around 1 million years before the Dino Doom, there's this big change happening under the Earth's surface. Way below where India's floating, a rock river starts forming, heating things up. And then, India gets hit hard. It turns into a sea of lava, like a fiery ocean. It's like a gazillion of dump trucks filled with lava slowly pouring out. These solidified leftovers are known as the Deccan Traps, like a super deep layer of hard lava covering a piece of land the size of France. And just like in our asteroid story, the real trouble comes from the air. For hundreds of thousands of years, sulfur dioxide spread like an unstoppable shadow. It was making the sky gloomy and the rain toxic. Food sources turned into poison, and oceans became acid baths. And then carbon dioxide took the stage. It was like a temperature button, flipping the Earth's climate upside down. It was a roller coaster of chaos. The ecosystems were stressed, food chains snapped, and species waved goodbye one by one. Both theories seemed pretty realistic. All the experts were having a big debate about which theory was correct and why the dinos disappeared. So, what is the real answer? Unfortunately, we don't know. Some scientists support one theory, some support the other one, and we're left scratching our heads. But hey, don't be too hard on the media or the scientists. They're all doing their best to figure out the mystery of the dinosaurs' disappearance. And maybe one day, we'll finally learn the real answer. So, stay tuned.